All right, the next part of the lesson is talking about what happens with segment lengths when you have intersecting chords. So in this, and you can click on here for more information, but it comes from similar triangles. In any circle, when you have two chords that intersect, the segment lengths in one of the chords, so in this case C and D, those are going to multiply to give you the same number as these two segment lengths. So let's say C was 2 and D was 6. Well, I know that's 12. So if I put a 2 and a 6 there, those multiply to 12, which means that these two numbers here should also multiply to 12. So if I gave you a 4 for letter B, that would imply that A would be, think about what A would have to be for those to be equal. 2 times 6 is 12. What number times 4 is going to be 12? And that number should be 3. So those have to be the same number when you multiply the products within the segments. That's intersecting chords theorem, and you can click on the source for more information. So let's use that relationship for the next set of questions. Question 5. On this problem here, especially on the computer screen, when you have a circle in front of you, and these problems you want to probably sketch it out and label. So I have AE, that's going to be 10. I have EC, put that as black. So EC is going to be 15. And DE is going to be 12. DE is in the same length as chord as CE, so I'm going to go ahead and keep that black. And I want to know, what is the length of EB? So EB here is in the same length as AE. So I'm going to put an X there. And then my relationship is going to be the two segments in that chord will multiply together to equal the two segments in the other chord. So I would say 10 times X, and that's going to be equal to 12 times 15. So 10 times X equals 12 times 15. Multiply 12 times 15 and you get 180. So 10 times X equals 180. Which means if you divide 180 by 10, you're going to get 18. So the value of X is 18, which means EB is 18. And you can double check that. If you plug in 18 in there and multiply it by 10, it should be the same number as when you multiply 12 and 15. So those should check out. So try letter B, check with your teacher. Let's go on number 6. All right, 6 is already labeled for you, so it's just like number 5. So you can try both of these. You know, you might get a decimal and that's okay, but you know, you're basically just going to say X times 16 equals 8 times 18. 16X equals 8 times 18. Solve that out, set it up, solve it out, and multiply and divide, and you get your X value. Same thing for letter B. So you can try that one on your own. All right, question number 7. 7 is a little bit different. Let's read through it. In the circle below, FM is 10. So far, we're looking at similar problems to the first one we did. MG is 6. That's along the same line, so I'll keep that red. PM is equal to 4. What is the length of PQ? Well, there's the difference right there. So they're not asking for MQ, they're asking for P to Q. So remember, PQ is the whole chord. That's going to be whatever PM plus MQ is. But we already know PM. PM is 4. We don't know MQ, right? So we're going to solve for MQ first, and then just add 4 to it to get the overall length to PQ. So you see that setup. It's going to be 4 times X equals 10 times 6. So 4x equals 60. And then 60 divided by 4 is 15. All right, I got x. Now, that 15 is the length of MQ. 15 times 4 is 60. 6 times 10 is 60. But PQ overall is going to be 4 plus 15. So that's actually going to be 19, not 4, or not 15. So PQ is the overall chord length, not just a section of that chord. All right, try letter B, check it with your teacher. Similar setup. And move on number 8. All right, question number 8. This is a big circle. I, again, suggest that you draw this out and label it. So let's start with what I have given. I have AP is 3. I have EQ is 4. I got PQ is 5. Notice that I tend to keep the segments along the same line, the same color, just so for our reference there. QB is 7. Oops, that's going to be the same color. And PD is 18. Well, I have a different segment, so I guess I'll call that black there. So that's going to be 18. All right, so we got 2 problems to solve on this one. Let's start with letter A. What's the length of CP? Well, CP is in the same chord as PD. So I want to know what CP is. So think about this chord here. Chord CP, I'll use the letters so we can kind of see the different breakdown, times chord PD, segment CD times CP times segment PD, not chord, because the overall thing's the chord, is equal to, now this one's kind of tricky because it's the breakdown here. P is that point where it separates them, okay? So it's going to be AP times from P to B. Got to go all the way to the end of the circle. So it's going to be PB. Not PQ, not QB, but PB. And remember, PB is PQ plus QB. So it's going to be 5 plus 7. So let's put in what we got. So for CP, I'm just going to call that X for now. PD is 18. So 18X. AP is 3. And PB is 5 plus 7, so it's going to be 12. So it's 18X equals 3 times 12. So 36 is equal to 18X. And 36 divided by 18 is 2. So CP, that little guy there, is going to be 2. Now letter B is very similar, but it's using the other segment. I'll go over all this with you and you can try number 9 on your own. So letter B, what's the length of DQ? So DQ is in the same segment as EQ. So let's set up another equation. All right, I would say DQ times EQ is equal to, now Q is our cutoff point here, so it's QB times QA. So we got to go to this endpoint there, so QA. And QA is a combination of 2 segments, just like PB was. QA is going to be 5 and 3, so 5 plus 3. So let's set that up. It's going to be, I'll call DQX, so it's going to be X times 4. And that's going to equal QB is 7, so 7 times 8. QA is 8. So 7 times 8 is equal to 4x. So 4x equals 7 times 8. 7 times 8 is 56. So 56 divided by 4. And that should be 14. And let's keep that blue here. So 14 will be this length right there. Actually, let's keep that red. 14. So 14 times 4 is equal to 7 times 8. 2 times 18 is equal to 3 times 12. Okay, that relationship holds. So 2 and 14. So you try this one. It's just like the last one. Different numbers, different chords in a different section. Check with me. And then the last one we'll do together is question number 10. I'll do letter A with you guys. All right, so it's the same formula. Look at what we're being asked. We're being asked to find dA, so it's one of those where we need the whole segment again, not just part of it. But in order to get that, we have to find x. So this problem is going to be the same setup, right? We got 9 times x equals 2x times x minus 1. I'll put that in parentheses. So we'll start with, we got 9 times x, so 9x equals 2x times x minus 1. Okay, 9x equals, let's distribute that. So 2x squared minus 2x. Now in these problems, they all have an x in them, so I'm going to divide that x out and get rid of the quadratic portion of this. So this is going to become 9 equals 2x minus 2. And we can add 2, which is 11. And then we can divide by 2 to get x. So 11 divided by 2 is going to be 5.5. X will be 5.5. Now we can answer the question. So what is dA? Well, dA is going to be the 2x plus the x minus 1. Now we have the value of x, right? We're going to plug in that 5.5. So 2 times 5.5, well, that's 11. And then we have 5.5 minus 1. That's 4.5. So 11 plus 4.5. That will be 15.5. So the length of dA, all that is 15.5. Boom. Y'all try that. And then the rest of your assignment is review. You can check that with your teacher in class, but it's just kind of circle equations, arc length, and area of a sector. So that'll be the end of this video, and look forward to helping you out with any questions you have in class. Thanks.